Section 7.1 Development of the Periodic Table. The discovery of the chemical element has been an ongoing process since ancient times. Certain elements, such as gold, appear in nature in elemental form and thus were discovered thousands of years ago. In contrast, some elements, such as technetium, are radioactive and intrinsically unstable. We know about them only because of technology developed during the 20th century. The majority of the elements, although stable, readily form compounds. Consequently, they're not found in nature in their elemental form. For centuries, therefore, scientists were unaware of their existence. During the early 19th century, advances in chemistry made it easier to isolate elements from their compounds. As a result, the number of known elements more than doubled from 31 in 1800 to 63 by 1865. As the number of known elements increased, scientists began to investigate the possibilities of classifying them in useful ways. In 1869, Dmitry Mendeleev in Russia and Lothar Meyer in Germany published nearly identical classification schemes. Both scientists noted that similar chemical and physical properties recur periodically when the elements are arranged in order of increasing atomic weight. Scientists at that time had no knowledge of atomic numbers. Atomic weights, however, generally increase with increasing atomic number, so both Mendeleev and Meyer fortuitously arranged the elements in proper sequence. The tables of the elements advanced by Mendeleev and Meyer were the forerunners of the modern periodic table. Although Mendeleev and Meyer came to essentially the same conclusion about the periodicity of elemental properties, Mendeleev is given credit for advancing his ideas more vigorously and stimulating much new work in chemistry. His insistence that elements with similar characteristics be listed in the same family forced him to leave several blank spaces in his table. For example, both gallium and germanium were unknown at that time. Mendeleev boldly predicted their existence and properties, referring to them as eka aluminum, under aluminum, and eka silicon, under silicon respectively, after their elements under which they appear in the periodic table. When these elements were discovered, their properties closely matched those predicted by Mendeleev, as shown in Table 7.1. In 1913, 2 years after Rutherford proposed the nuclear model of the atom, an English physicist named Henry Moseley developed the concept of atomic numbers. Moseley determined the frequencies of X-rays emitted at different elements were bombarded with high-energy electrons. He found that each element produces X-rays of a unique frequency. Furthermore, he found that the frequency generally increased as the atomic mass increased. He arranged the X-ray frequencies in order by assigning a unique whole number called an atomic number to each element. Moseley correctly identified the atomic number as the number of protons in the nucleus of the atom. The concept of atomic number clarified some problems in the periodic table of Moseley's day, which were based on atomic weights. For example, the atomic weight of argon, atomic number 18, is greater than that of potassium, atomic number 19. Yet the chemical and physical properties of argon are much like that of neon and krypton than like sodium and rubidium. However, when the elements are arranged in order of increasing atomic number, rather than increasing atomic weight, argon and potassium appear in their correct places in the table. Moseley's studies also made it possible to identify holes in the periodic table, which led to the discovery of other previously unknown elements.